Hey guys, okay, so I just wanted to record the gas law notes so when I'm gone you'll have them. Just remember, one of the first things you need to do is make sure you have all your conversion factors from last class. So remember, everything is equal to one another. Most of these we wrote down last class. A couple of them are new. Okay, just remember PSI stands for pounds per square inch, so that's just there so you have it. And actually we're not going to use the new one, so all of this is the pressure at sea level. Which is also going to be the standard pressure. So if it says standard pressure, any of those will work. You just pick the one that belongs to it. Okay. Next thing, we're going to go through these laws. I'm going to talk about them, and then we're going to work a few problems that go with them. So Avogadro's law is first. Remember, Avogadro deals with moles. And before actually I do any of that, just remember that N is moles, P is pressure. This is from the Pogel from last time. V is volume, and T is temperature in Kelvin specifically. Okay, I did leave the Kelvin and Celsius conversions on the board. They should not be erased, so just make sure if you need them, like you didn't write them down last time or you lost your notes, it'll be on the board. So Avogadro's law does deal with moles. This law is volume over moles. Okay, and remember in the Pogel, when it asked for the algebraic expression, we just wrote like V over N. But now they need to be equal to each other because really algebraic expressions are equal to one another. So hopefully you remember from your Pogel, this is a direct relationship. I do want you to make sure you write that down. That means if one goes up, so does the other one. Okay. Boyle's law is next. It's pressure and volume. Okay, and this one is an inverse relationship. That means if one goes up, the other one goes down. They do not go the same direction. Okay, Charles's law is V1 over T1. Okay, which again is a direct relationship. Okay. The biggest thing you need to know with all of these is if you have to calculate temperature, they must be in Kelvin. I did write that at the top, so don't forget that. Also, your units have to be the same. Like if we have two different volume units, that's not going to work. Or if we have two different pressure units, that won't work either. So just make sure you're paying attention to that. The last thing I want to add is combined gas law. So over here on the side, okay, this combines all three of these. Okay, so the way the combined gas law works, like let's say we've got more than two variables, which means we can't use just Avogadro's, Boyle's, or Charles's law. And so at that point, we would say, okay, let's say we're not using moles. They didn't give us moles. We're just not going to use N. And so at that point, that would be our new equation. Or we could say we're not going to use volume. They didn't give us any volume, so we just don't use that one in our equation. If you have questions, please reach out. I am going to work some problems now. These are on the back of your note sheet. So just go ahead and flip it over. Okay, there are some other laws on here on the back. I'm only expecting that you know those 4 gas laws for now. We'll address the other gas laws when I get back. Okay, so the first thing you need to do is determine what variables we've got. I've got a temperature, I've got a volume, a pressure, and another pressure. Okay, they did not give us a second temperature, so we're not using that. They want to know what V2 is. So we've got V1, P1, and P2. This is going to be Boyle's law. I do want you to identify what law it'll be. Okay, which is P1 V1 equals P2 V2. So let's go ahead and solve that. I've got 1 atmosphere. It's P1 times 3.6 liters equals 2.5 atmospheres times V2. So I'm looking because it says what is the volume at this new pressure. Now I do want you to remember all of those numbers in the problem itself where it wrote them are 3 sig figs, so don't forget our answer will need 3 sig figs. So algebraically, to get V2 by itself, I'm going to do 3.6, and I'm going to divide by 2.5, and I get 1.44 liters. That is my answer. That is 3 sig figs. We're good. Okay, next one they gave us, let me do it in another color so we don't lose them. They gave us V1, they gave us T1, they gave us T2. So this one is volume and temperature, which is going to be Charles's law. All right, so we're looking at V1 over T1 equals V2 over T2. The biggest thing to remember is we must convert to Kelvin by adding 273. So T1 will be 290. Our V1 is 300. V2 we don't know. And T2 in Kelvin will be 283. Okay. So please do not tell me this is the butterfly method. That is something cutesy your teachers did in lower levels of school. We're going to cross multiply and divide. So we're going to cross 300 times 283. We're going to divide by 290, and that'll give me V2. Okay. Okay, so these are all going to be 3 sig figs. It comes out to 292.75. So we're going to say 293 milliliters. The reason the unit is milliliters is because 300.0 was in milliliters. All right. Let me switch back colors. I've got a volume in liters. I've got a pressure in millimeters of mercury, and I have a temperature. And then I've got another temperature and another pressure. So they're asking for V2. Okay, so when you have more than 2 variables, we're going to use that combined gas law. Notice though there's no moles, so I'm just going to leave it out of my combined gas law. Okay, don't forget our units have to be the same for each thing. So I don't want to do it in millimeters of mercury. I want to do it in atmospheres just because atmospheres are easier to work in. So I'm going to divide 700. Okay, we're going to do 760. Okay. So I've got 0.921 atmospheres times 500 liters, that's a lot, divided by 200 Celsius, but remember that needs to be in Kelvin, so we're looking at 473 Kelvin, equals, my new pressure is 30 atmospheres. I don't know V2, my new temperature in Kelvin is going to be 293 Kelvin. So here, we're still cross multiplying. So we're going to multiply 0.921 times 500 times 293. Then you're going to divide that by the 473 and the 30 atmospheres. So V2 equals okay, make sure you put the bottom in parentheses if you're not using a calculator that has that fraction function. Okay, I get that V2 to 3 sig figs, because 30 has 3, 20.0 is 9.51 liters. Okay, the reason it's in liters is because that's what my other volume was. Again, remember your units must be equal on both sides for the problem. All right, last one for examples, and you're going to do your packet. We've got a volume. I've got a moles. I've got a second volume. So if we just had volume in moles, this is Avogadro's law. Which is V1 over N1 is V2 over N2. My V1 is 11.2 liters. N1 is 0.5 moles. V2 is 20 liters. I'm looking for N2. We still cross multiply. So I'm going to do 20 times 0.5, and then I'm going to divide by 11.2. So N2 equals 0.89, but really 20 and 0.5 are only 1 sig fig, so we're looking at 0.9 moles. Okay, if you have questions, you can send me a message on Remind, things like that, but this is just basic algebra and that you can work that out. So if you need help though, so let me know. The packet you picked up is homework. We will grade it next class. Y'all have a great day.